All right, we'll start with the joke before we talk about angle relationship in the circle. Why was the chord upset with the tangent after the race? Think about it for a second. Because they came in secant. Okay, it's not funny. All right, so let's take a look at reviewing what we did yesterday. All right, we need to find the angle Russ. So right here, we know that this angle here is 90 degrees because it creates this 180 degree arc. So that's 90. We know that this is 50. All right. Oh, well, we know that this is 50 here, right? And then this is 90. All right. So that's 180. Well, Well, Russ, oh, that's across from the 50 degree angle, isn't it? Well, this is just half of that, so it's 25. All right. And we're to find A. Well, we know 90 is equal to 3 times 14A minus 12. And divide by 3, divide by 3. So I get 30 is equal to 14A minus 12. I add 12 to both sides, so I get 42 is equal to 14A. Oh, divide by 14, divide by 14, and I get 3 is equal to A. All right. Find the angle measures of ABCD. Remember, this plus this has to be 180 degrees. So we know that 4y plus 13 plus 5y plus 5 is equal to 180. All right, so that's 9y. Let's see if I can add right today, or on this one. So 13 plus 5 is going to be 18. It's equal to 180. Okay, this is good because both of these are divisible, or everything here is divisible by 9. So 9y is equal to 162, which is still divided by 9, or divisible by 9, divided by 9. And so I got 9 goes into that once. I have to carry a lot over, carry 7 over. So y is equal to 18. But I'm not done. I need to find the actual angle measurements. So 19 times 5 is going to be 20 times 5. That's 100 minus 5. So that's 95. The way my math's been going of late, I kind of want to double check this one. All right, we feel good about that. Well, that makes this 85. And let's double check. So 4 times 18 plus 13. All right, so we're working out. It's working out. All right, so using the same logic, we know that 15x plus 35, so right here, plus 25x minus 15 has to equal 180. 15 plus 25 is 40, so we get 40x. 30 minus 15, thank goodness it's an easy one to figure out in your head. So subtract 20 from both sides, so I get 40x is equal to 160, so that means x is equal to 4. Love it. All right, so here we go. That's 100. 100 minus 15 is 85. Which makes this 95. Let's double check. So 3 times 4 is 12. 12 plus 7 is 19. 19 plus times 5 is 45. 95. All right. So good things are happening already. All right. So we've got some more theorems. Now we have angle relationships in a circle. So what we're looking at right here is we're looking at our first situation, where we have a circle. Don't you just love circles? And we have a point on the circle that's creating a angle like this. And I'm going to call this point C. How about, let's call this point B and point A. So this angle measurement is going to be equal to, so measurement of angle ABC is going to be equal 1/2 the measure of arc AB. Now that's just an extension of yesterday, right? So you have a point on the circle, and so the arc that's created by it is going to be twice the measure of the angle. Okay, that's not too surprising. But that's not an angle relationship in a circle. So here we have one that is in a circle. So this time I'm going to have two chords, and they intersect inside the circle, not on the edge. Well, let's call this A, let's call this M for fun, B, and let's go Y and Z for these points here. So here's the cool thing about this one. We know that the measure of angle, this is the big one right here, measure of angle AMB is going to be equal to one-half, oh my God, excuse me. Okay, I'm back. Sorry about the phone call. It's going to be 1/2 the measure of arc AB plus the measure of arc YZ. All right, so to recap, the major angle here, or actually these angles are the same, aren't they? Because they're vertical angles. So it doesn't really matter. This angle or this angle will be half the sum of the two arcs. Okay, that's not too bad. Let's take a look at another wonderful thing. All right, so why was the secant joke funny or not funny? Well, it requires us to know what a secant is. So we're going to draw a circle. And so a secant is a line that goes through the circle. Wow. And so right now I have drawn two separate secants. I know you're very, very excited about my secants. Okay, so we have our secant here. And in this case, they meet outside of the circle. Outside of the circle. And so let's call this one A, B, and C. Now, notice how inside the circle, the angle measurement was equal to half the sum of the two arcs over here. It's got to be related somehow. Now we're outside, right? So we have the measure of angle ABC is going to be equal to 1/2, but this time we're going to take the major arc AC, and we're going to subtract the measure of, let's call this Y and Z. Y and Z. Woohoo, yay! Very exciting. Okay, now there are some variations of this that we can talk about really quickly. And here are the variations. The first variation is all the same equation. The first variation is if you have a secant and a tangent. Now a tangent is a line that touches a circle in exactly one place. So it's the same basic idea. This angle here will be half the measurement of this big arc here minus this small arc here. Another situation that involves some secants is when I have, is when I actually have two tangents. Pretend it's a tangent. This angle is going to be half this big angle minus this angle. It's all the same rule. You need to remember that it also applies when you have tangents, not just secants. All right? So these two rules here, added with the first rule that we talked about yesterday, the one where you had a circle and a point on the circle, where this distance is twice this distance. These three rules together can put together some really fun angle measurement puzzles. Oh, you want to do some fun puzzles? All right, that's the next page. Go ahead and try the example problems on the back, and then check the video to see how you did.